warm greetings and a warm welcome to all for another session of Friday Water Thesis Club. The idea of Friday Waters is to wet the Fridays with fun-filled and yet fruitful activities for the future generations. Friday Waters has water talkies, book reading, thesis club, and water arts. The focus of Water Thesis Club is on bringing the student scholars who have done or are doing thesis alias research on water matters to the session in order to discuss with them the making of the thesis, research, and the issues around the subject covered. I am Ekta Gupta, the moderator for today's Thesis Club session. I am joined by Dr. Sonia Gupta, professor at Watson University, as a discussant for today's Thesis Club session. For today's session, we welcome our guest speaker, Ms. Fatima Saeed, to share her research on synthesis of mixed matrix membranes for water purification and energy generation. Fatima Saeed is a chemical engineer working in CSIR-IICT in membrane separation laboratory. Her working areas involve water and wastewater treatment with membrane separation techniques. Presently, she is focused on synthesis of mixed matrix membranes for organic water and gaseous separations. She is working on membrane techniques like pervaporation, vapor permeation, gas separation. She is looking forward to work on membrane reactors with inert or catalytic membrane for different applications. Welcome again, Fatima. May I now invite Dr. Sonia to take the session further with her. Over to you, Sonia.
Thank you, Ekta. Welcome once again, Fatima, to the Thesis Club, Friday Thesis Club. And thank you so much for taking up our invite and sharing your presentation. We see that the topic, while of course being steeped in scientific theory and appropriate technology, is of great relevance today in today's water and energy-starved world. So with this, the screen is all yours. Fatima.
Thank you so much for the invitation. And now I would like to start my presentation. So my working area is before entering into membranes, I have worked on wastewater treatment only. That is, I have worked as a research and development engineer for 1 year. Then I have worked for like junior research fellow for 2 years. Then I have worked as senior research fellow for 3 years. Also, I have qualified graduate aptitude test in engineering 2 times. And during my whole tenure, most of my work includes downstreaming and wastewater treatment, also development of new technology for water generation. So my PhD thesis also involves like 4 objectives. Basically, my core area is synthesis of membranes. So we will have like different type of membranes, like organic membranes, inorganic membranes, biodegradable membranes. Like there will be different type of polymers. Based on the polymers, we will have different membranes. So like how my PhD research started and how I got into all this stuff. So I would like to elaborate. Like if we look through polymers, like today one of the major problem with the polymers and membranes, like if we see RO process for desalination, there is a major problem for disposal of waste. So they are asking for biodegradable substances.
Just a moment, I'm so sorry to interrupt, Fatima, but could you go to slide presentation mode, full screen mode?
One.
Right, thank you.
Like there is a need of biodegradable membranes. Also, like we need to see the energy consumption. Like if we see the reverse osmosis process for desalination, it requires very high amount of pressure. So how we need to decrease that energy consumption to make the process viable and economical. Our major objective is that like less cost and economical process. If we see the whole industry and all, like the 2 major things that we see is the cost and viability of the process. So biodegradable membranes will have their own drawbacks. Like if we use them for water treatment, if we see they are biodegradable, most of the natural polymers will get dissolved in water. So how to use them for water treatment and wastewater based applications? So we are looking on for different polymers, like how we can modify them to you, and how we can give them strength to transform into a membrane so that it can be used for different wastewater treatment based processes. Like if we see my first objective, that is synthesis of ZIP-71 loaded membranes for butanol recovery from simulated fermentation broth. Like if we see from the point of biorefinery. So fermentation broth is one of the major product of biorefinery today. Fermentation broth, mostly it is dilute water solution with the product. The product is butanol. Nowadays we are using ethanol and butanol as fuel. So the product butanol is in very less concentration. Suppose we are doing distillation. So if we want to remove anything which is very less, suppose we say we have a mixture of 100 ml water, in that only 10 ml is butanol. We are going for distillation. It requires a lot of thermal energy because we need to evaporate whole of water. So we are looking into alternate process, that how we can extract that little amount of butanol from that water so that it can be a viable process. So I have developed some membranes. These membranes are like mixed matrix membranes. So why I have went into mixed matrix membrane? Also, there is one problem in that fermentation industry is that product inhibition. Product inhibition is like nothing. If the butanol forms into the fermenter, if we won't remove it, it keeps on forming and it inhibits its own reaction mechanism. So we have to remove it continuously from the fermenter to increase the yield of reaction. So keeping in mind all those aspects, I have developed this mixed matrix membrane. So I have used one hydrophobic polymer to synthesize these membranes, but the problem with the polymer is it is not having any mechanical strength. So I need to provide it mechanical strength. To provide it mechanical strength, I made the membrane into composite. So for that composite form, whatever bottom layer I have given, that layer also should have specific properties. Like in membranes, we will have different types, hydrophilic membranes and hydrophobic membranes. So my major motive is to develop hydrophobic membranes. Also, here I have used a process called pervaporation. Pervaporation is nothing like, that is a combination of permeation and evaporation. That is like an alternative process to distillation comparative to conventional distillation process. In conventional distillation, what we'll do is we'll take two components. Whenever one component which is having higher boiling point, that will be in residue, and the lower boiling point will go upwards and convert into vapor. Then we will condense and collect the product. Here the process is different. What I have done is here is reverse. I have removed the higher boiling point. How I have removed this? I have developed a membrane. Also, in like if you can see, there are two chambers here in my diagram. So one is like my feed chamber at atmospheric pressure. One is like permeate chamber at negative vacuum pressure. So what I'm doing here is I am based on the interaction between the membrane and the component that I want to remove. Based on their interactions, I am converting that component into gaseous form. That gas is coming and getting collected in the trap, and then that gas I am condensing and I am removing it as a product. So here I have like in this specific membrane based process called pervaporation, there will be like different mechanisms of molecule transfer. So my process followed the sorption diffusion mechanism. If you see, I have shown here mechanism also. The components are getting sorbed on the membrane surface, like membrane surface will be there. They will get absorbed on that surface, then they will diffuse through that surface, and then finally they will get dissolved at the permeate point of the chamber. So here, what I have done is like my membranes were having little bit less efficiency in removing the desired product. So I have converted my composite membranes into mixed matrix membrane. Mixed matrix membrane is nothing, but we will have a polymer matrix. In that, we will load some solid particles. So that solid particles will help to enhance the interaction of the component that we want to remove and the membrane. So it will increase the interactions. Based on that interactions, more molecules of that components will come on my membrane surface. They will get diffused and they will get dissolved. So with the help of this process, I have recovered butanol. If you can see here, these are the images of my 3-layer membranes. This first is the same image of the that novel support layer I have prepared to provide strength to the membrane, and this is a 3-layer membrane that I have prepared to recover butanol from fermentation growth. Now, if I would like to go to my next work, that is like synthesis of biodegradable membranes for water removal. If like this is also like one we can say like one problem we encounter, we will have different type of reactions, chemical reactions. One is the very famous esterification reaction. So that reaction is like equilibrium limited reaction. Equilibrium limited reaction means we have to alter the equilibrium parameters, either temperature, pressure, or concentration, to achieve the yield what we want. Again, if we are increasing the temperature, pressure, that is like consumption of more energy. So how we can reduce the energy here also? So here what I have that and that too here I have like 4 components. That is the reaction between an acid and an alcohol. It is giving me an ester along with water. So it is reversible reaction. That reversible reaction. So it will be like thermodynamically limited. To overcome that thermodynamic equilibrium thermodynamics, I have prepared these membranes and I have done continual removal of water from that chamber. With the help of continuous water removal, I was able to overcome that equilibrium that was limiting my conversion, and I have achieved almost 95% of conversion in that chemical reaction. So here what I have done is I have taken the polyvinyl alcohol polymer, that is a biodegradable polymer. So I have cross-linked that polymer because as it is a biodegradable polymer, it will have the problem of swelling. That membranes will encounter the problem of swelling in water. So I have cross-linked that polymer. Also, I have loaded my catalyst based on graphene oxide on these membranes to convert them to mixed matrix membranes. So one funda is that I can use a membrane only to remove water, and the other is I can load the catalyst in my reaction chamber and the reaction can go on. But if I will keep the catalyst powder in the reaction chamber, the reaction zone will be very far. So to overcome that drawback also, I have immobilized my catalyst on the membrane surface, and I have provided a specific reaction zone for the reaction to take place so that it can be fast. The acid particle and the catalyst particle will get reaction zone very close to the separation zone. So here I have combined 2 processes in one process, that is reaction and separation. My reaction is going on the membrane surface, and the products are getting diffused through the membrane, and then they are getting dissolved on the next side of the chamber. So this is one of my kind of membrane reactor in which I have used membrane as a dual functional thing, as a medium to do the reaction as well as the medium to do separation. So here also we can save a lot of energy. This is like 2 unit operations I have intensified into 1 unit operation. So my next work is like synthesis of hydrophobic membranes for direct methanol fuel cell application. So this methanol fuel cell application have a very good advantage. Like we can directly put that fuel in that fuel cell, and there will be different 2 electrodes, anode and cathode. We will have to put the catalyst on these electrodes. So basically, we'll load the catalyst on anode, and like commercially and all, we are using platinum ruthenium catalyst. So here I have changed my catalyst, platinum nickel catalyst, platinum nickel from platinum ruthenium. Again, this is very costly. Also, there is one problem encountered in this fuel cell is that there is so much chances for the platinum inhibition, or we can say like poisoning of platinum poisoning. So what will happen here is if we see whatever proton here, whatever membrane we will use, that will be termed as proton exchange membranes. Proton exchange means it will allow only H plus protons to pass through the membranes. Other than that, nothing can pass through it. But like it will have a certain efficiency. if we see that commercial Nafion, we are using commercially Nafion membranes. If we see in market, we can use that membrane that will have very good iron conductivity. But the problem is that we can't use that membrane above 80 degrees centigrade. It will start decomposing and all that swelling and more crossover, fuel crossover will be there. So here one problem we'll encounter in this type of cells is like fuel crossover. Fuel crossover is nothing. If we'll keep on using the membrane, this methanol will also come along with hydrogen ions, because that if the membrane swell means its pores will get enlarged. So it will allow methanol also to pass through, and it will come in our cathode chamber, and it will destroy our catalyst. So there also we are developing the membranes to overcome this fuel crossover and to enhance its power density. Whatever membranes we have to develop, it should not compromise the proton conductivity, ion exchange capacity, and power density of the membranes if you want to use in that fuel cells. So here also I have developed one proton exchange membranes that is like I have used two polymers. Actually, this my work is not published, so I am not interested to disclose so many details. So here I have used two polymers that I have blended. Actually, one polymer I have functionalized, but while functionalization, I have loosened the strength of that polymer. So to give the strength, I have blended that polymer with one more polymer. So then I have got a membrane with proper strength and proper fuel cross, like there was very less fuel crossover and very good ion proton conductivity, ion exchange capacity, and power consumption. So my next work is like synthesis of polymeric beads for wastewater treatments. So here what I have done is, in my most of the membranes, if you have seen, I have used either 2D or 3D nanomaterials with the membranes. Why I have used is I want to give more surface area for the membranes so that more ions, more molecules get absorbed on its surface and it can move through its surface, and I am able to remove more. So here what I have done is MOFs, if you would have heard, like metal organic frameworks, they are having organic and inorganic linkages. Inorganic, like one metal will be there, around it there will be organic ligand. So these 3D metal organic frameworks I have used here. So my motive here is to remove heavy metals like mercury, cadmium, lead, etc. So if we use these 3D materials, there will be more sites for the metals to get absorption. So that University of Oslo has prepared its first time. So they have given the name like UIO. Basically, it is zirconium based octahedral framework. They will have like benzene dicarboxylate and some MOFs will have terephthalic acid kind of linkages, like carbon hydrogen linkages, and some will have carbon hydrogen and nitrogen linkages. So they will be like free catalyst sites, free sites to get either the molecules or the ions get absorbed. So this is like my ongoing work. It is on the verge of half it is completed, half I need to complete. So here also I have removed successfully very low concentrations of mercury, lead, and cadmium from industrial effluent. Like we will have like different effluents like battery effluent, acidic effluent, like mining effluent. They will have different concentrations of these ions in that effluents. So, taking those effluent and making same amount of concentration of similar of that effluent, I did some preliminary trials and I am trying to improve the properties of my beads. So what I have done here is, here I have came from membranes to beads. Why I want this metal organic frameworks will have very low water stability. Their structure will get destroyed if we use them for more time in water. So to increase their I am looking in the areas to increase their hydrolytic stability. So one way is like I captured them into the polymeric beads form. I have captured them, and then I have done adsorption on those beads. So like that, I have achieved my heavy metal ion removal from industrial effluents. So if you can see here, this is my inner and outer structure of that polymeric beads with loaded that MOF particles, and this is the X-ray crystallography of the prepared MOF particles. So this is my ongoing work. It is somewhat more less remaining to completion. Also, we have the very good quality with this MOFs is like we can functionalize those structures. Already they will have very high surface area. If we add some functional groups also to this, those MOFs, we are able to remove some toxic gases also. Like we will have carbon dioxide, like H2S, acidic gases, and several other flue gases if like we have from coal fired industries and all. So we can use this type of MOFs in that area also. In gaseous
I think we are losing her
applications
voice.
also. And next matrix. Next is mixed matrix zip loaded membrane for biobutanol recovery. This is also a published work in Biochemical Engineering Journal. Also, apart from this, I have also worked on other areas of membrane treatment. I have other publications in nanofiltration. Like this here also we have done modification of reverse osmosis membrane that were like waste membranes, whatever we will be throw them. So we have cleaned it, we have enlarged their pore size, and we have came from reverse osmosis to nanofiltration, and we have used them for again for wastewater treatment. Here, apart from wastewater treatment, I have done some solvents treatment also. Like there will be one alkali we use in semiconductor and pharmaceutical industries. Here also we have removed so many metal ions with the help of membrane treatment, nanofiltration treatment. Also, we have done a patent on during COVID that we have, me and my team have designed mask that is like 4-layered mask that we have developed, and this is overall whatever I have done till now. If any questions are there, they are welcome.
Right. So congratulations, Fatima. I think the topic that you have taken up is extremely relevant, and we of course hope that you will be soon completing your PhD very effectively. But we also hope that your research will be utilized for the greater cause of humanity. So that is when science will be really, really effective. Yes, your presentation, as it should be from a chemical engineer, is very technical. But as you know, this session is for any persons who is associated with water. So we will have different types of people looking in on your presentation today. And therefore, as Mansi says, it may be highly technical. And let us ask a few basic questions, okay? Before we can, if we have time, then we go in for the deeper questions. For the basic questions, go like this. That is, what is a membrane? If you can explain that, what is a membrane with examples from daily life, everyday life, maybe that will be, a starter for the consumption of, for the consumption of every other person who's watching. Yes,
Okay.
please.
Thank you so much. Membrane is like we can say a barrier. If I say in our daily life, if we see human body, we'll have kidneys. So that is like a semi-permeable barrier that will allow some components to pass through it, and some components it will reject. So if we see a human body, our kidneys, they will reject some, they will allow only some ions to pass through, and it will reject, that will get as urine. So that is like a reject of a membrane. So this is very basic example of a membrane.
It's a very good example for understanding. Yes. So, yeah, the next question that is hovering in our minds is, you've used these two terms, hydrophilic and hydrophobic. If you could tell us what the difference is. Yes.
Actually, if I say technically, we'll have a different technical definition for hydrophilic and hydrophobic material. If I say in very basic terms, hydrophilic means whatever components are water loving, that we'll call as hydrophilic components. If we see the word hydro means water, philic means loving, so that are water loving. Hydrophobic means water hating. So if we see like our organic compounds, that all are like water hating, we can say that all are like hydrophobic materials, like organic compounds.
Right. Yeah. So I'm just thinking mixed matrix membrane.
Sonia, one example
Yes.
I can
Yes,
say,
Nirali.
like plant life, lotus leaf. If you put water,
It
the water
slides.
will be like that only. So that is the hydrophobic nature. Okay, that is phobic means phobia, fear.
Yeah.
So rejecting, it is not. So like filtration, the membrane, or like chai ki channi, that is filtration and all. So something will pass water
Pass through.
through it, something will reject water, like that, hydrophilic and hydrophobic, like. So water loving,
Absolutely.
water rejecting.
Okay, thank you so much for the explanation, Nivedita. Also, just wondering, mixed matrix membranes have been around for a while, I mean, right? And for for biomedical and for environmental applications too. So, because we are mostly interested in water treatment, that is our area of excitement. So, we would like to understand it a little better in the sense that how would you compare other available components or techniques, other membranes available to mixed matrix? Yeah.
Mixed matrix is like a type of membrane. Basically, if we say a membrane, like I have said, a semi-permeable barrier.
Right.
So if we can take any polymer and we can convert it into a membrane. But as I said, there will not be specific properties like strength. First property is strength and stability in harsh environments. Like if suppose we say seawater, it will have so many salts. So it should have stability on all those harsh chemical environments. So like that, our like we have modified it and turned into out a mixed matrix membrane. So to give its strength, alongside to give it the desired properties that we want to apply for a specific application. So suppose I give you example, like we have nanomaterials also. But as I have done my second work, like if we use anywhere nanomaterial, suppose in water treatment only, nanomaterial is like particles. We have to pack a bed and all, make a packed bed, and then we have to give some pressure and pass the water, and then it will get purified and it will come. But that is like immobilized. Immobilized means it can move anywhere. So there will be very vacant channels and all, and so many losses will be there. So if we take those nanoparticles and put it on a membrane, we are immobilizing. We are providing a proper road for the process to go through. There won't be any empty channels and losses and all. So all those things we can overcome through these mixed matrix membranes.
In another way, I can say this is actually improvising the membrane property to enhance the filtration efficiency. Okay, so the quality of membrane will improve by this particular phenomena, mixed matrix phenomena, to have better efficiency in filtration.
Okay.
So,
Yeah. Right. So we are also wondering that if we are to think about application for, say, the common user, right? So the question of affordability, the question of water loss, all this will have to be coming in. And then the question of how suitable it is for the market. So how would you be able to tackle those, from the user point of view and also from the provider point of view? Is there any thoughts on that?
Can you please repeat the
Yeah,
question?
so I meant that if this technology is to be used on a larger scale by people, then what are the issues? For example, the affordability and the amount of water that will be lost. And then I'll
Okay.
come to the second part. Yeah.
So actually, whatever first process I have mentioned, the losses are very less in that process. But the thing is, like, the pressure there I have to apply is more. So there I will lose the cost if I want to apply industrially. So what we can do is we can merge that process with adsorption process if we want to use industrially. So preliminary treatment I can give with adsorption, and then tertiary treatment I can give with that process with least cost.
So you think it will be a commercially viable product if it is to be used?
If I combine it with adsorption,
Right.
it can be
That's
commercially viable because I have prepared those membranes keeping in mind the commercial membranes.
Wonderful. So that is really good to know. Yeah. And also, like you said, that the volume of water lost is very low. So obviously, you're comparing it with something, right? So what is that benchmark that you're comparing with?
Like if we see in that is like a distillation process. It is an advancement of conventional distillation process. So there we'll see losses as whatever feed we have taken and whatever product we have got, and due to temperature there will be some products that will go into environment, like they won't be able to condense. Here we are
Right.
condensing, that
Correct.
we won't be able to condense. So suppose if I am taking 100 ml of water, suppose as feed, so I am losing only 1 or 2 ml of water as vapors that I am not able to condense.
That seems to be very, very efficient. Yes, absolutely. So you have also mentioned that it's a clean energy source, which we understand by now. But pollution, it's a zero. I mean, how does one reach that zero figure, zero emission of pollutants? Because there are certain inputs over here, which is looks like this is going to add to our pollutant load. Yes, please.
That I am also looking into. By the end of my PhD, I will be able to find.
Okay, so we are not concerned with that much with the biodegradability of the product.
Like suppose my second work, if we see that I have used that is like biodegradable polymer. So what I can do is I can redissolve it. I can redissolve and I can separate that polymer and catalyst. Then I can reuse. And if I decompose also, its end products will be water and carbon dioxide. Like this is only only carbon hydrogen. So like that I can go for its decomposition.
Okay, okay. And there's a question, I think, coming up from Nivedita also, which says that how do you know, how can you make it happen that the organic and the inorganic filters will be compatible?
Yeah, like if we see like this MOFs, if I elaborate, I have already mentioned that they have like very less hydrolytic stability due to that organic and inorganic weak bonds that are
Right.
weak bonds. So if we capture them into something like in my fourth work, I have captured them into like beads, and so if we capture them into membranes, so we are able to stop, like we are able to increase their stability, and chances are there that more we can then uh, uh, make them on large scale. Once we have achieved their hydrolytic stability, transforming into various forms, then we will be able to scale up.
Okay, yeah, that is also good to know. Yes, Mansi, would you like to jump in and ask a few questions at this point?
Yes, please. Thank you so much for bringing me in because I was really getting to get into it because, I'm always the devil's advocate in these kind of conversations. And I want to become the voice of the people who have no clue about what's going on here. First of all, you're talking about water purification, right? I just want to clarify myself first. Fatima, are you talking about water purification?
Yeah, yeah.
Okay, because I didn't get that, so I really need to know. And what kind of water purification? Is it the domestic waste, industrial waste, or mixed waste?
See, that I have already mentioned like four objectives. In first objective, that is like industrial broth, if we
So
say.
actually, yes. So you were presenting couple of projects, huh?
Yeah.
Independent projects, and that also made me go round. Where should I ask question? So I understand that your PhD is based on multiple experiments, and then you bring and publications, and you bring them together, and that makes your doctorate. So that's a very good way to look at trial and error on experiments. So my question is more on methods, to be very honest on it. Um, uh, Two questions. When you do multiple methods in PhD, your, of course, one point agenda is to look at how to purify water. That's your overall objective, because society is facing problems on water pollution. So now that you have presented to us four methods and more, as you mentioned in your reference, I want to know from you, how far have you been working on PhD and pre-PhD? I saw a very good resume you have. If Fatima has to start her own, water entrepreneurship or a scientist,
Startup.
where does where does Fatima see a scope to, become like another Sufia Khan? I'm just giving one example from our Wiki Water Resource Council, who actually became an entrepreneur from scientist. So if Fatima has to choose out of these many experiments which she's conducting during her PhD, where do you see the light? Which experiment you think will be seeing the light of the day faster than anyone else, where you can just jump into and become a research entrepreneur? And my question is
Like
not the topic. I mean, sorry, but I just want to ask like a common person and a decision maker.
Like I have done in this, I have done like so many industrial waste
Yes.
processes, like industrial wastewaters I have treated. So if in future I want to do something, I am very much interested to generate a centralized domestic wastewater treatment system,
Wonderful.
like we have in developed countries. So my main motto is to get like least discharge from our homes. I don't know how much. I don't know the like exact tons how much we are wasting daily, the
So
all
if
the
you should be able to
bathing,
get us, yeah,
kitchen
will
and
you?
all.
Nice. Will you be able to get us some machine or membrane? Just like, we have started doing home composting. Will you be able, like, and also, in my childhood, there was no atta chakki which was available at home. Now it is available. So I'm just, I'm thinking loud, and it is extremely important for a researcher to ask this philosophical question. Then you are contributing directly to the society. So will you be able to offer in my lifetime a small machine where I flush my own water and I get it back to use in different way? Then I think there's a big
Sure.
contribution from your side. So my question to you follows. Sonia, may I continue for another question or so? Okay. And
Absolutely.
Nivedita is smiling because she knows where I'm heading for and why Fatima is here and why I am also here. So my next question to you is, when scientists are making these wonderful patents, and I've been also involved in the evaluation side of many of these kind of science. I've not done any innovation, so that keeps me naive and safe. But when you do these kind of patentings and innovations and experiments, I understand those which fail, you don't take it further or you experiment it later on. But I'm curious now, those experiments which succeed in a smaller scale, what kind of incentives are available in your field to upscale them? Because see, I'm already imagining Fatima to offer me from 10-15 years from now some machine in my house which is going to recycle my wastewater, and I'm going to use it for my Well, I don't know, for flush and for garden or for car washing or even for drinking for that matter. I don't know your extent of research. So where do you see scientists, young scientists like you taking up startups and upscaling these smaller projects, which should not really just get shelved into patents and publications? Again, not a technical question, but life question. Over to you, Fatma.
So actually, if you see that whatever patent this we have of our mask, this our team has actually. So this, like if in daily life, if we face some problem, suppose I have given an example of domestic water that will generate, like if I think on like how to get rid of this, how to get it, one day or the other I will develop some process to treat that water and I will get clean water. So this idea of developing a mask also came during COVID times. So there was mask shortage. We were not able to access mask, and also my PhD guide came up with the idea that whatever membranes that we are throwing, we can reuse, we can remove its layers, and we can incorporate those layers in that mask. Then we have modified. We have done all the certifications and all. Then we have came up with the idea of mask. So it was like we were finding the problem to our solution. We found that solution, and then that solution we have done a patent. This was not done to create a patent. This was done
Very
to
good
find the
observation.
problem to our solution, but it has come into a patent.
Very good.
So, like that, we can do different things. Like if we have different problems in our mind, and if we keep on thinking that I have to find its solution, we find it, then we will try to improvise that solution. Obviously, if we want anything on commercial or large scale, we need to improvise whatever we are doing on lab. So, like that, it will come out.
Okay, thank you so much. I have many questions for this kind of research, to be honest, because I'm such a dumbo on these subjects. But I will hand it over to Sonia to understand more, particularly when we talk about all these experiments, they also have byproducts, which we never discussed, you know. And I think, Sonia, you had raised this very lightly, and also Fatima had mentioned that she still has to work on it. But water pollution is a serious problem, and treating water itself also creates another level of pollution. So over to you, Sonia. Thank you so much, Fatima. And 10 to 15 years of time, I'm really looking forward to having that little machine in my house. And if you need something to get that startup done for you, you know where to reach. You have Nivedita, you have me, you have Sonia, and everyone to help you out. Thank you so much. Over to you, Sonia.
Thank you.
Thanks, Mansi. Yes, that definitely looks absolutely poised for a startup. And yes, so the question that I had wanted to ask, but right now, Mansi, you just taken this to a different level of marketability and research and reaching out in society. So I'm really not I've kind of lost my bearing. But yes,
because our series
yes,
is to connect science to the society,
absolutely. I
and
think that's
let
really
these
wonderful.
serious scientists be heard by the society, but then
Yes.
society has to understand their language,
Right. And it's no point sitting in a silo. You have to be able to reach out and
Yeah.
make sense. Absolutely. So just one thing that was rankling was that, when you are doing, it's a what, so the two things are there. I mean, one is the water purification, and then later we are coming to the energy generation. So in the water purification process, there has to be some kind of residue, right? The water is evaporated and it's condensed on the permeate side and gone. But what happens to the residue? What do we do with it?
So if you are talking about my first residue or second residue, if we see that my second residue is a reaction mixture, I'm getting my products in that residue. So that is nothing a waste. So, and one, if we talk about my residue, that is also like product mixture, that is like component of a reactor only. So that stream will also go again to the reactor only. So there is nothing like waste.
Oh, that seems to be a win-win situation. Absolutely. right? That the waste is being again sent back to the, that's really very,
Reactor.
yes. So I don't think, Mansi, we need to get into more scientific explanations at this point.
I think so.
Except, yes. So rather we would talk about, let's say at this time, how, because mixed membrane is something that has been there for a while, I'm just wondering that the energy production that you're thinking about, which I don't think is very well known, that is your absolutely novel area of research as well. So in the energy production, how will you compare it to other renewable sources that we know already? How will you compare that?
So that energy generation is from fuel cell only. So nowadays already we are having electric vehicles. So all those vehicles will be using these fuel cells only. So this is like whatever we are using at present, that only, in that field only, I have done developed that methanol fuel cell for energy generation. Because nowadays our fossil fuel are exploiting, so already we are moving to hydrogen. So these fuel cells we can use in future also, like for small devices.
Up until now, so that is your that's the way you're looking at it, right? As in small devices. Okay. All right. So because we, for us, the non-renewable sources are whatever is available to us naturally, right? But this is also going to be a big additive in that process, and the scale of it seems very suited to individual households or communities. Am I correct?
Close the door. Yeah.
Am I correct in thinking that the scale of the product that you could actually bring out would be very suited to individual households and communities? Am I correct in assuming that?
Actually, whatever research I have done, that is very much based on industrial
Okay.
things.
Okay. Okay.
Household research, I will start after completing my PhD.
Okay, great. That's good to know.
Very well
because
put.
That's good to know. Yeah, so wonderful. I think we've had a very vibrant conversation with you. There were only 6, actually 5 slides, but it gave us a lot of food for thought and a lot of room for discussion also. So with that, I think we should be now coming to a close, Mansi. Ekta, what do you feel? Yeah,
Yeah. I hope I'm allowed to ask few questions.
of course.
So, thank you, Sonia and Mansi, for giving an insight to the presentation and raising so many questions. I have learned that science to entrepreneurship, yeah, definitely a scientist to entrepreneurship journey is very innovative. And definitely we need the startups who can work on the waste management so that we can create the zero waste industry as well as for the domestic. So now, whenever we talk about the waste management, usually people will say that why should we do it? Why don't you go to the industries? Our domestic waste is not that much. Industries are creating the more pollution. So my questions are how this individual lab, as scientists are doing the experiments in their labs, but again, my question is that how these experiments, which are in the vicinity of the labs, can come to the community, where the community can contribute to the experiments. They can give you the real view that how the experiments done in the labs are useful in the real life. Also, whatever the residues, we were talking about the residual also. So these residuals, how the membrane, what will be the life of the membranes, cost effectiveness, when we talk about the commercialization, we are talking about scientist to the entrepreneurship. So whenever we come to the entrepreneurship, there must be the ROI. So there should be the market. And when we go to the market, everybody will ask about the ROI. And ROI is what will be the long-term benefits. If somebody investing now, right? So is it cost effective? It may be expensive now, but it may give the later on benefits that will compensate. And today's expenditure will convert to the benefits, profits later on. So these are the things, I'm not a scientist, I'm an entrepreneur. So I have that thought that how these lab experiments can be beneficial for the society, as well as it gives the ROI to the common person, whether it is industry, as you're talking about that your research is on industrial waste. So how the industry can use these membranes, and what will be the reusability lifetime of these membranes, and how the current process they might be spending a lot on current process, and so many industries, small industries, may be ignoring these processes just because they can't afford it, or they are ignoring. So how we can motivate them with the cost effectiveness, as well as the ROI, what ROI they will get later on. I'm not talking that presently it can be, but later on with these developments and more experimentation, and how these small industries can be involved in these experiments, so that we can get the real data. Experimental data is definitely different than when we come to the implementation phase. So is it possible to correlate and come to the community experiments?
If we talk about community, like we will have very, very different scenario in community if we compare to lab. So in community, we cannot come to experimental level, but we can change like some habits or some segregation treatments or some small ponds in homes, like that sort of things we can do at community level. But at all, we should have a centralized facility for the treatment if we want at community level. Or else we should have some small portable devices. Like I have talked that I am very much interested in kitchen wastewater and domestic wastewater treatment. So we have to make a system like in our home, we have to incorporate those small portable systems where, like she said, that she needs clean water if she wants flush. After that, the clean water should come out. If we are washing utensils, after that also clean water should come out. So, like that sort of things we have to develop, and then we can use in our daily lives.
May I ask a burning question, Ekta, before you say thank you? Again,
No, I'm
because
not
I'm
saying that.
always grilling PhD candidates and counseling a lot of them around the world. So, Fatima, it is not a thesis or research question, and no technical. When you are interested in, let's say, this kind of work, what keeps you motivating to do something else in your experiment or that kind of work? Because you are already waiting for PhD to be over to really jump into working on domestic water, and right now working on something else. Probably you may not see career in this because you see genuine problem in domestic water. So what keeps you motivating or working on something which may be not your future way of doing? Of course, the approaches will be same, but you have, I really like the fact that you have clarity that you want to work on the kitchen wastewater. And how
So
much time is left for your PhD? Sorry, how much time you are left with your PhD?
very less, all 4 to 5 months.
That's a bad question for a PhD scholar, but anyway. Okay. Please, how do you keep yourself motivated?
So, like if I think of like what to do after PhD, obviously, like there will be a question. So, and then if I see here, I will keep on working on some or the other industrial problem, like whatever feed streams I'm using, that is somewhere they are encountering some problem in industry, and then we are giving the methods like this new method like that. So already we have a problem in our household, like domestic. So I have to start from there. If we want if we want to save some water, or if we want to do some reduce wastewater generation and all. So that way we can contribute to society also, and it is beneficial to us also. Like we will have like we will not face any water shortages, all that sort of problems we only have to face in future. So why don't we start from our homes only, like that
Bingo, bingo, you
sort of.
nailed it. You just nailed it. The source, you have to work on the preventive method while you're working on the cure approach, because your experiments are cure methods. If we reduce the waste from our, so charity begins at home, or be the
Yeah.
change you want to see in the world. Thank you so much, and sorry for barging in again. I'm really a nasty person in these things when it comes to PhD scholars. Ekta.
Yeah. Thank you, Mansi. I'm also waiting for the day when I'm not throwing any wastewater in the drain and all the water is reused at my home, as well as the industries, the biggest wastewater problem in our rivers. So, thank you, Fatima. Thank you, Dr. Mansi, and thank you, Professor Sonia, for giving me this opportunity to be with all of you in these sessions. So now there is an announcement for the next sessions. So we have Friday Thesis Club on every third Friday. Here's the next. Please join us for next Friday water session. We invite you to Water Arts on 24th November, 5 p.m. IST on the Goa River Draw with Ria D'Souza. The link to join the session is in the chat box. Please circulate and please join us. And forthcoming Wednesday for water session on 22nd November at 5 p.m. Do join the discussion on the gap in the plan to tackle the plastic waste. Also, join us. Please register at the given link in the chat box. And for the further information and regular updates, please visit our site www.w4w.in. And you are requested to circulate the link so that more and more people can join and give their views and share their knowledge. Yes, for this is not the ending. Actually, after every session, I must say that it's a beginning for the new journey. So join us on every third Friday for Water Thesis Club to learn more research from the more innovative scholars. So thank you so much. Thank you all. See you all on next Friday. Thank you.